In this video, we're going to look at combinations of transformations, which means more than one thing is going to happen to our function. So we're going to use a graphing calculator to graph g of x equals negative absolute value of x plus 5 minus 3 and its parent function, and then we're going to describe that transformation. So what is the parent function of g of x? Well, because we have these absolute value symbols right here, that tells us that our parent function is an absolute value equation. So that means our f of x is going to be the absolute value of x. So let's go ahead and pull up our graphing calculator, and let's clear out what's in there. And let's graph these. So let's start with our absolute value equation. So to do that, we're going to go to Math, and then we're going to go ahead and we're going to arrow over to Number, and that first option, that's going to be what we want to choose. So we'll have the absolute value of x, and that will be our parent function. And then we're going to go ahead and put in our g of x as well. And so we're going to put in a negative, and then do that whole process again to get our absolute value symbol. So negative x plus 5. I'm going to hit our arrow over to get out of the absolute value bars and hit minus 3. Now I want you to think about what that minus sign in the front, that negative sign in the front is going to do, what the plus 5 on the inside is going to do, and what the minus 3 in the back is going to do. Let's graph it and find out. Oh wow, it looks like it's off our graph. So we're going to have to adjust our window a little bit. So we'll hit Window and adjust our window to the following, and then we'll try graphing it again. Ah, that's better. Now we can see both of them. So here we can see our red parent function and our g of x in black, and we see that it has moved over to the left, moved down, and it's reflected. 3 different things have happened. Let's go back and let's sketch that. So as we go to sketch it, we're going to remember that our parent function didn't change, but our g of x did. Remember that it moved to the left and it moved down. In fact, it moved to the left 5 spots. We might need to rethink our sketch because I don't think 5 spots is going to fit. Nope. We're only going to see part of the graph, so we better adjust that. There we go. Now that we've scooted it over a little bit, we can move to the left 5. 1, 2, 3, 4, 5. And then down 3. 1, 2, 3. And then remember that it reflected. And so now we can see our sketch of our g of x. So let's write what happened. Our g of x moved to the left 5, down 3, and it reflected across the x-axis.